Okay, hello students. Here I'm working on Unit 5. Uh, this is scaling the input, lesson number 9, Unit 5, Algebra 2. So the goal of this lesson is I can describe the effect of a scale factor on the input of a function, and I understand the difference between the scaling outputs and scaling the inputs. So based on this, I'm going to straight away dive down to the problem that we have is here, the first one. So okay, here are the graphs of two functions. You'll be given two functions f and g for which determine the value of k so that g equals f of kx. Before we go this, we need to know that the f of x is the main f graph. If you see f, that's the original graph. This is the original, and g is the new graph. That means either it is in other words, if you have x-axis and the x-axis and the y-axis, and let's see if this is the original graph, and you may have a one graph which is horizontally stretched, maybe this point right here, which goes right here. So that will be so. This is the f of x. This is the f of x, and this will be the new graph gx. So if it is stretched, so you can see that it is stretched on horizontally to the right side. Then so what is the we need to know what is the scale factor. So so we need to know what is the scale factor, and I call this as a C. And then what is given right here is gx is equal to f of kx. So in this case, this C is scale factor C is 1 over k. So that k is one C is 1 over k. And the C basically is if this point is, let's say this point is x2, okay, and if this point is x1, this is x1 and this is x2, then the C basically is x2 over x1, and K is x1 over x2. So these are the things to be noted down. So what is C is, it is you can also remember it is a new divided by old, and k is actually the old x1 is the old divided by x2. So we are going to use this all the time. So by how much this is stretching towards, so we want to know how much this is stretching here, right? So that means it will be always x2, and you can see this is that x2, this is that x2, this one x2 over x1. So basically it means the new, if let's see, uh, this is the new distance, see, from the y-axis, and this was the old one. So it's the ratio of x2 over x1. To understand that, what is the meaning of this? So when you try to plug it in over here, so that k basically is the number which is x1 over x2, and if I write this gx, it's equal to, I can write it as f of x divided by 1 over k. So basically it is f of x over c. So that c is basically, it decides whether it is stretched to the right side. So if it is horizontally stretched, means that's when c will be greater than 1. And if it is shrinks, so I can draw another one graph this way. So this point, so this is the point, it either stretches, so this goes stretches. That's when c is greater than 1, or this is when c is smaller than 1. So that's kind of to be understood. Okay, let's go directly to the actual problem. Now, if you see this first problem number 1, you see the dotted one. I think I messed up. Which one? Let me see. Which is that? Did I forget? One, two, three, and there was another one which I forgot. I think. Okay, I think I need to get that. Okay, here the point is, if you see this, let me take the arrow. Uh, so this is, can I take a little bigger? Uh, what's this? So this point, so this means, uh, okay, I think now I can take this and change the color. Yeah. So this point, which is right here, which is at 10, 0, moves to the right. So there you see, so this point is stretched. Every point now is stretched there. Maybe this point, which is right here, stretch here. So all these points are stretched, like see. So we want to know what factor did it stretch. So the goal is to get that kx, not k, so the k. Remember the k is x1 over x2 directly. Okay, but if okay, let's see what is x1. Now here, this is the original function f of x, and the solid is so this is the gx graph. So this is the gx. So this point moved here. So the 10 moves to 10. So that's x2, right? So that becomes 10 divided by 30, and you get 1/3, and you're done. So that means the new function gx is f of kx, but that kx is f of 1/3 x, and which is the same as f of x divided by 3. See the down number, that's c. So in this example, I was talking about that c is 3, which is actually 1 over k, which is 1 over k is 1/3 here. So which is 1/3 like this, and which you get same as 3. So c is 3. So basically what it means is the g function is also f, this one, gx is this part. So there is a 3 at the bottom. That's the scale factor I was talking about. Scale factor is not k, but scale factor is 1 over k, and that is 3. And 3 is greater than 1. That's why there is that. Okay, let me cancel this. Mm, okay. So this is problem number 3. And now the question is, which one is fx and gx? So gx is the solid, dotted is the, so let me use the blue color here. So the blue one is the old one, that's the old. Okay, so old is x1, this is old, and the new one is the gx, this is the gx, and gx is x2. Okay, so the k is x1 over x2, which is 0.693, and divide by 0.2. So you use the calculator and uh, you get 2.5. So this is the case. So you are done. So your answer is gx is f of 2.5 and x. That's answer. But you want to write what is the scale factor. When the scale factor is different, so you have to be careful here. I want to write here. See this part? Let's cancel. So this part is the scale factor. So I'll write shortcut. Scale factor is c, which is 1 over k. It's basically 1 over 2.5. And if you work this out, then you get 0.4. So that c, which is 0.4, is less than 1. So there is a horizontal stretch by scale factor of. So here I can write. So there is a horizontal string by a scale factor vector 0.4. So that's it. So hope that helps. So that it means this graph has shifted, is stretched. See this part, sorry, shrinks. This shrinks, everything shrinks by a scale vector. You see. Even this point, it goes this side. So it goes this side. Everything shrink towards the y-axis and become the red graph. Hope that helps. Let's do next one. Now in this example, so I'm going to use the f of x is the new graph, old graph. So this is the old one. This is the old one. Okay, I'm going to use this point. The bottom part is better, and then what it does is there is a. I want to because of this point is right here, and if I reflect this point, it means it is this one. See. So that means the blue in the first is it's like a stretch. It goes like there is a stretch like this. This point will be somewhere here, like this. So this point moves somewhere here, maybe. And that is becomes so basically what I'm trying to say there is a this is that stretch and then it reflects. So the main thing is the blue graph has to be uh, has this blue graph has to stretch and then shift. So that means we need to the k will have to be the gx that you see has is f of kx, right? So it's not just uh, k will have to be negative because you are going to reflect and get the black graph on the left side. This part. So what is first of all what factor did it go like that? We want to know what is that k. So let's put that k first. K is always x1 divided by x2. So in this case, what I'm gonna do, I'll take this point here, see, or you can take this point also. This is so the let me clean. So this is the old one. This is x1, okay, and now there is a point here. This point I want to think of, which is reflection of this point, which is 2, 1. That's the x2. Or you can directly take this as the x2 after reflection. So it is like x1 divided by x2, so which is minus 2. Sorry, the first one is 1. That's the 1. This is the 1. So minus 1 divided by x2 is minus 2. Oh, sorry, I made a mistake here. So x1 is 1, and other one is minus 2. So this is equals, yeah, k. So that is minus half. So your function becomes g of x is f of kx. Now the k is minus half of x. Or it also can be written as f of minus x over minus 2. So I can write this as this, so this way. So where the down number is minus 2, basically it means stretches by a scale factor. What that basically means is, uh, so horizontally vector c, which is minus, which is minus 2, but because so that minus means stretches by scale factor of I'll put 2, and then reflects over the y-axis. So hope that takes care. So reflects over the y-axis is minus 2. Or you could just say horizontally stretches by a scale factor of c equals minus 2 means it stretches and then reflects over the y-axis. Okay, this problem, they give you something like this, right? Decide if the reasoning about each of the following is correct. So Andre, one student says this is the this is obtained from f by scaling the inputs by a factor zero point 0.4. Now it's here the factor zero point 0.1 the k. So he's talking about uh, the new one is 0.0 f of 5 of x, and you can see here the axis of all these four x's is is replaced by 0.5x, and that sorry is replaced by 0.1. So this is, that means this is a horizontal. I would There is a horizontal kind of movement, but then this horizontal movement is not by a scale factor of zero point 0.1. So this is only this, but the right scale factor is it is x over 0.1 is 110, so this become 10 here. So there is a horizontal stretch by a scale factor of 10. Then Andrea says, so Andrea says there is a vertical shift of the graph of AF down 100. Now, if you see this part here, if you put x equals 0 here, if I plug in this equation, if I plug in 0, f of 0 is 0. So this graph has a scale factor of 0, but this one has a scale factor, I mean, the y-intercept is 100, and this y-intercept is 0, so how can it be? So uh, it's, it's not going to be, so the original graph that you see here, it passes through this one. Say I can always take the opposite of minus 5 is 5, and this is plus 2 is minus, opposite is minus 2, and this plus 5 is opposite is minus 5. And since there are four of them, so the graph is something like this actually, something like this. So maybe the one that they show here is it is the graph which is vertically shifted up 100 units, so not down. So that's a mistake. So this is she's wrong. Claire is not correct. The right way could have been the new one. This graph which you see is is shifted 100 units. So it's like this is shifted 100 up here. Hope that helps. And finally, there's one more question here. Diego says this is the reflection over the y-axis. Remember, whenever there is a minus there, so this minus that you see, it means the graph which was maybe this was the graph. Now this graph, that minus means we could have been reflected over this. So this could have been this one, say something like this. So this is the could have been the reflection. This is so whenever the minus means it has to reflect over the x-axis. So Diego is saying this is the reflection over y-axis. No, that's not how it is. Hope that helps. Okay, now this problem of bacteria population in 1000 is given by this, and D is the number of days since the first measure. The function G, so this is the new one of bacteria population. This one is given in weeks, so many weeks from the time it measures. So you have to write down G in terms of F. So first of all, let me type it right here. First of all, days, number of days is equal 7 times. So if you see 7 times 6, right? So instead of that, I can write D equals 7 times W. So what we can do is the f of D, so f of which is D there, we can write is as f of 7W. Okay? And that we want to write in terms of G, so that is equal GW. So G, the new function W. So in the equation f, this one, the new function will be G of W will be equals Because 30 remains the same, multiply by 2, and you go up, raised to, it means instead of D, you just write 7W. That's it. You're done. That means this is, so basically what I'm saying is, so this basically means is G of W is 30 times 2 raised to 7 W. That's it. So this is the relation. That means G of W is F of 7W. So that's the main thing. So if you just write this much, that's correct. Hope that helps. Okay, question number 4 is the height of the hot air balloon is given by, so after m minutes takeoff, it is given by this function. Okay, so the question is how many minutes does it take for a balloon to reach the 200 feet? So what all you do is you put 100 because this is 200. So you have 200 equals 16 and you want to know how many minutes, right? M. So therefore we solve for M. M equals, you just, okay, I'm sorry. So you can write therefore M equals 200 divided by 16, and if you do calculator and you get 12.5 and you're done. That's all it is in seconds. Uh, in minutes, sorry. So that is in minutes. Then the second question is, another balloon is taking off 5 minutes later, okay, and rises at the same speed. Now, this is the most important part. It goes by the same speed. I had done the similar problem in the class. So you're supposed to write an equation of G, where GT is the height in feet of this balloon in terms of. Now, remember, uh, what is what this means. If this is your f of m, you're supposed to write the g. How is the g related to that g of m? And remember, because it takes off 5 minutes later, so the gm will be equals 16 and m minus 5. So why minus 5? We already seen that because 5 minutes before is what the height of G is. So, sorry, height of F is because the G is taking off later on. So it has to be minus 5. If you want to graph this, if you see the next question is how do we graph? I think in this case, so I'm going to use the original function uh, since it is 16. So if I put f of m is 16, and because if I put m is 10, f of 10, we want to know how this is. This will be 160 because if I put multiply 10 to 16, you get 160. So that means where is 16 will be somewhere here. So I can graph. So when this is where it takes it off and it goes like this. So that's the original f of x. And the g of x will be the same, but goes this way, the same speed. So that's how it looks like. So at any point, at any let's see, uh, 15. If this is 15, this point, 15 minutes, whatever the height is 15, let's say this height, maybe this one, I don't know, but that's like, looks like it is like 70, between 50 and 100, almost like maybe 80, I don't know. Let's put it 80. So this is like 80. The same will be, this will be that height. Oh, I made a slight mistake. Uh, so the original one is this one, okay, and the new one goes from 5. So that's my mistake. Yeah, I'm sorry. So this at any point, let's say at 10, this point and this point, say they have the same output, which is almost like 90 maybe. So 5 minutes before F output is the same as G, and that's why you write that the new one is 16 and M minus 5. Hope that helps. So reflecting f, this is what here is a graph. So f is given. This is f across the reflecting f across x-axis, and then across the line y equals 1 takes the graph of f back to itself. Tyler said this means it is odd. No. So what is the meaning of odd? Is, remember, odd basically means if you have a graph. Let's see if this is the graph. Okay. First, if you reflect, this graph will go. The first you need to reflect over the y-axis, and then you reflect the one, and then it goes back on the red one. See, so that's what the odd function is. That f of minus x. Okay, so that means this means reflecting over the y-axis, and then you put and you change the output. That and then if you do this and you get back your original function f of x, that's the odd function. Or you can also say f of minus x is minus f of x. Okay, what this means, if you reflect over the y-axis, you get a green one, and this means if you reflect over the x-axis, you go back to green one. See, so that's another way to say. So Tyler is wrong, and we don't agree with Tyler because to say it is odd function, it is totally different. The definition. Now let P be a model. This is the next one. Population. But the uppercase T stands for in thousand, the number of slots T years after 2000. So you can see this gives you years. It means this is 2000. This is 2000. Okay. So 5 years after this. This is 2000. Okay. And some data is given. Okay. So the population 5 years after 2000, that's the population. So this is the data which gives, and we need to write down for this data what is the new function, and that new function is this one. And only thing, what is the meaning of pt? So this one is the this is the pt, the big one. Uppercase pt is the population. We need to write down based on this small pt. So they gave us p of t is already being given, which is 1.05. Okay, this actually is as if like the population. This means population was like 1000, and this is like 1 plus 5%, 5 over 100. So that's already given to us 5% here. I think somewhere they give us, let me know. I think they gave somewhere 5%. Anyway, so based on this, can we write the uppercase function? Now the question is, so we want to know how much this has gone to. So in this function, let's put t equals 10. So I'll put a t equals 10 here. So this will become lowercase. So p of 10. I'm replacing instead of t, I'm putting 10. So p of t will be 1.05. Oh, sorry. So let's put this pt in the function here, raised to, so here let's put over 10, and we'll see what do you get there. And what I did is, so I opened the Desmos calculator just to see how it works. So I took 1.05, you can see this, and put raised to the 10, and I got this number. So what I wanted to do next is, in the data it was showing 10 is 20, so we want to, so what I did next was, so there it was given 20, so I divided 20 by 1.628889, and you get 12.27. See, so that means, so you get 12.27, right? So that means your new So the new PT, they asked us what is P of t equals k times lowercase p of t. And now we got this. This is that scale factors by how much it gets stretched. So that means it should be 12.27 times p of t, or it is 1.05 t, and you're done. Remember, this is how it is. So they're asking us, the question was, what was the new one, the data, in the problem, you see, this is the data. We want to have a function. And they wanted us to know what is that k. So this part, this k is the important part. What is, by what scale factor is the old one, means this one gets stretched. So, and you all you do is this 20, you put 10 here. What I did is, in this equation, the one that is here, I put 10 is 20, right? So then I got the answer as 12.27. So that means the output. So out this 20 you get by multiplying 12.2721, which is right here. So hope that makes sense, and you get the answer as this whole equation you get. We are done. Thank you for watching, and yeah, hope that helps you. Even that's too much of messed up here, but I just wanted to do this video so that some of you may want to know how it helps. So the main thing is, goal is make sure you write all these steps. Again, I repeat, uh, like how you get this is the main thing. In this equation there is a vertical stretch. So this part means there is a vertical stretch or shrink. Now in this case, k that we got is 12.7. There's a vertical stretch by scale factor of 12.7. That's all that means. So the data here, that function is 12.27 to this data. See, this was given to you. And even if it was not given, you could figure out if they had to give us that the population is growing by, if there was 1,000, here one, as I say, if there was originally there was 1,000 and it was growing by 5%. So 5% means 1 plus 5 or 100, which is this is 0.05, add to 1 is 1.05. We got that whole thing, whatever that they give us. Okay, thank you, and make sure you write all the steps.